Okay, how many tangent lines to the curve y equals x over x plus 1 pass through the point 1, 2? So this is actually a hyperbola. Okay, so you typically learn that in Ontario in grade 11. So what I want to do is actually first do long division. Right? X divided by x plus 1 gives you 1. Subtract and you get minus 1 as a remainder. So what that means is that x over x plus 1 is equivalent to minus 1 over x plus 1 plus 1. Okay, that's what it means. So you should know how to graph this. Okay, so this is a hyperbola with center located at minus 1 and 1. Okay, so there's the y-axis, x-axis, okay, and because it's negative 1, it's reflected on the x-axis. So typically, it's up here. But because of that negative, it's going to be down here like this. Okay. So the question is, from the point 1 and 2, so 1 and 2 is about there, how many tangent points do we have? Okay, well, you can see, you can draw one over there. You can also draw one over there. Okay, so the next part is, at which points, like what are these actual points? What are the coordinates? Okay, so we know that this is 1, 2. So let's just say that right there is A, and the y coordinate, we can just plug in A in here. So we get A over A plus 1. Okay, A over A plus 1. So the expression for slope for this line is 2 minus A over A plus 1 over 1 minus A. Let me multiply the top and bottom by A plus 1. So you get 2 A plus 1 minus A, 1 minus A times by, well, 1 plus A. Okay, I just wrote it backwards because this is a difference of squares. We get 2A plus 2 minus A, 1 minus A squared. So we get A plus 2 over 1 minus A squared. Okay, so that's an expression of slope. Okay, just using the definition of rise and run. Okay, we can also get one more expression. Okay, and we can get that from differentiating x over x plus 1 using quotient rule. dy over dx is going to be x plus 1 minus all over x plus 1 squared. If you plug in x equals a in there, you get 1 over a plus 1 squared. So we can say these two are equal to each other. Okay. Okay, so the common base will be a plus 1 squared times by 1 minus a. So this one here, the a plus 2, needs to be multiplied by another, like, a plus 1 or 1 plus a. So I'm sort of switching using the, sometimes I write 1 plus a, sometimes I write a plus 1. So keep in mind that they're exactly the same thing. And here I gotta multiply that by 1 minus a. Okay, so let's simplify the top. We get, actually let me write a plus 1, it'd be actually easier. Okay, so a squared plus 3a plus 2 minus 1 minus or plus a. Okay, so to solve for this, we just have to be concerned with what value of a will make the numerator 0. Okay, so when the numerator simplifies to a squared plus 4a plus 1. So using the, let's complete the square, or you can use the quadratic formula. I'm going to complete the square here. So I'm going to bring this 1 over to the other side and add 4 to both sides. So a plus 2 is plus minus root 3. So a has two values, minus 2 plus root 3, or minus 2 minus root 3. Okay, so let's go back up. So that right there, okay, this x value right here is minus 2 minus root 3. And this one right here, this x value right here is going to be minus 2 plus root 3. It's asking for at which points. So the y-coordinate, let's plug that into a over a plus 1. So minus 2 minus root 3, minus 2 minus root 3 plus 1. So the y-coordinate is minus 2 minus root 3, minus 1 minus root 3. That's the y-coordinate. And this is the x-coordinate at that point. Okay, maybe I'll just write it out just to make it look neater. Note that I can multiply top and bottom by negative 1. I get 2 plus root 3 and 1 plus root 3. Okay, now here, again, for the y-coordinate, I can plug in here, right? So minus 2 plus root 3, minus 2 plus root 3 plus 1, minus 1 plus root 3. Okay, so that coordinate right there is minus 2 root 3, and I'm just going to write it as a root 3 minus 2 and root 3 minus 1. Okay, so that's the other coordinates. Okay, so these are the 2 points where the tangents are touching.